Welcome back to Coronavirus University, my remote location during the pandemic. I'm Rob Kussner, a professor of mathematics at UMass Amherst, and I'm the course chair for Math 235 linear algebra this fall. Last time we were discussing a linear system that arose from an experience 10 years ago, a real experience at the post office near where I am now. And we wrote out the system of equations, and I guess I asked you to solve the system, and you've probably done that by now. The solutions are going to be whole numbers, so in fact, it's going to be pretty easy for you to find it just by guessing, and maybe you did that. Of course, one of the unknowns we actually know, so let's fill that in. And the problem really was to solve for those two variables. And I hope you've done it. If not, I'm not going to give away the answer yet. But I want to show you one other way we might look at it, and actually gets to really the other side of this course, which is that there's geometry in linear algebra. And I think I'd like to emphasize that not only in my lectures, but I'm hoping all the other instructors and I will be doing that during our class sessions as well. Anyway, so what is m equals 29? Well, I can think of B, L, and M as really a three-parameter space: the big sister's age, the little sister's age, mom's age. And it's like three space that we live in, or maybe it's, since we only allow integers, maybe it's more like this lattice, okay? But if we did the exact age, we'd have real three space. And m equals 29 describes a plane in this space, okay? And if we like, you can think of it to be the plane of the whiteboard, in which case maybe I'll draw the b-axis going this way, the l-axis going this way, and the m-axis is coming out of the board right at you, okay? Okay, so this would be where m was 29 rather than m equals 0 if we had the coordinate axis. But that's sort of the three space BLM space, okay? And the equation m equals 29, this purple equation, I've drawn a picture of it. It's a plane. It's the plane of the whiteboard, okay? What about the other equations? Well, they would also correspond to planes in BLM space, but since I've already sliced things with this plane m equals 29, we can basically do what Descartes taught us 400 years ago. We can represent these equations involving just the two variables b and l as equations in the plane m equals 29. So what are those equations? I mean, what do those equations represent? Well, they're going to represent, in the plane, this will be a line in the plane, and this will be another line in the plane. What are those lines? Well, let's see if we can figure that out. One solution to b plus l equals 10 occurs when b equals 0 and l equals 10. Another solution occurs when l equals 0 and b equals 10. And the solutions that are on that line to b plus l equals 10, I'll draw like this. See if I can draw a line. And of course, it continues into the negative parts as well, but let's just draw that much. Okay. And what about b minus l equals 4? Well, again, when l is 0, that says b equals 4, so that's that point there. And if you like to write it in slope-intercept form, you'll get a slightly different format for this, but it's not too hard to see that this line has slope plus 1. Okay. It's actually a line perpendicular to this one, so it actually looks like this. And the solution of this system of equations is described by the intersection of these three planes. So I said planes. Well, this line in the m equals 29 plane really is the plane that comes out from the board towards you and includes this line, so that one. And this line here, B plus L equals 10, is this plane. Okay. So I have three planes intersecting, and the solution, here's the solution. It's the intersection where three planes plane defined by m equals 29, the plane defined by b plus l equals 10, the plane defined by b minus l equals 4, those three planes where they meet. So that's the solution. And if I have three planes in space that, in fact, these meet perpendicularly, these lines meet perpendicularly and they're coming out perpendicular to the whiteboard plane, it's a unique solution. And if there really is a unique solution, as this illustrates, that means you guys should have all gotten the same answer. And we'll see when we meet whether that's the case. Okay, so the geometry actually gives us information about what the set of solutions of a system of equations looks like, linear system looks like. And typically for three equations in three unknowns, the three planes will meet in a unique point. Now, I'd like you to think about this till we meet next time, what other possibilities might happen. So what are the other possibilities for the set of solutions? Okay. Sometimes you might not have any solutions. What's that situation with the planes that's defined the system? Sometimes you might have infinitely many solutions. What's going on with the planes? Do you ever have a finite number of solutions that isn't one or none? And if you have more than one solution, i.e. infinitely many, if that's what you get, how can you describe that set of solutions? The main topic of this course is to give a more precise notion to what the set of solutions looks like, how many parameters it has, and where it's located in the space of unknowns. Okay, so that's where we're heading with this. If you actually wanted to solve the problem using geometry, where would B and where would L be? Well, B, the big sister, would correspond to the B value, so that would be that number, and L would correspond to that number. And you could probably now eyeball the value of B and L that solve that, but perhaps you've already done it algebraically. But geometrically, it's now pretty easy to do this. And since we know it's a whole number, if you didn't figure it out already, that should give you a hint. More next time.